When the spring arrives, the warm air gradually melts the ice, causing the thickness to decrease at a constant rate. After 3 weeks, the sheet is only 1.25 meters thick. Write an equation slope-intercept form for the ice's sheet thickness, measured in meters as a function of time, t measured in weeks. Okay. So the prompt here, this part, there's two points, two data points or two ordered pairs that you can get from this. Could you attempt to identify either of those for me?
Um, so meter thick sheet of ice.
So for like normally it's XY. Let me help better. But in this case, it's T for time and thickness S.
So it would be, so for the second point, it'd be 3 comma 1.25.
That's right. So that's good. 3 comma 1.25.
And so that one's 0 comma 2.
It would be 0.2. Yeah, very good. Okay. So from here, you want to find the slope. So the slope, you probably know by now, is y2 minus y1 over x2 minus x1.
Mm,
Go ahead and calculate.
1.2. All right, I got -1/4. Let me simplify it.
Okay, so that was yeah, -1/4, or maybe because it's decimals, maybe go -0.25. So that's your slope. Okay. Now, one of the things I think could be hard here is because they're using these awkward variables T and S. So use X and Y. Okay, just use that. Just write Y equals MX plus B for now. That's your M. Right. So the minus 0.25 X plus B, the B value is 2. Comes from this ordered pair up here. Sometimes you just get it. If you don't have a nice ordered pair 0, 2, you put 0 in for X and then you find that B is 2. Is that clear, or do you want more explanation on that?
I think I get it.
Okay. I mean that it's nice in this problem that they do that, but it's not realistic. So here's the thing though, is they want it in terms of T and S. So that's where you go back to your original mapping of variables. Okay. T is really X, Y is really S. So S is equal to minus 0.25 P plus 2.
Got it.
All right, so that's part A. Is that okay?
Yeah.
Clear? All right. So the next thing here is to sketch the graph and label the axes. So again, if it's easier, just like think of it in terms of X and Y. If like if this is bothersome, go back to this one and graph this. But it starts at 2. And then it goes down 0.25 each time. And so your scaling really matters here. You also need to indicate that it can only be in this range. Like, so yeah, this is 1, this is 2, this is 1, 2, 3, 4, 5, 6, 7, 8 weeks. Because like it doesn't melt. I mean, after 8 weeks, it doesn't go negative, just there's no more. So you got to be careful here that you don't extend the graph.
Got it. Yeah, that makes sense.
Okay, so and so in terms of like, you have to put T, you have to say that's in weeks. And this is S, which is in meters. Something like that.
Got it.
Oh, and actually part C does answer my question, which is, should the line have two errors on each end? So that in the beginning of the course, they're more critical and stuff. So like even this little bit here at the end, you really want to just only do it like that. Like really make it clear, it just goes to those two endpoints.
Got it. And then for the Y thing, you would just say that like then after the ice is melted, you can't go negative.
So like you can't have negative no, and you can't really have negative time. But you may want to, this is one of those where you really want to, uh, you may want to talk to your teacher and ask them kind of like, what language are they looking for?
Got it.
That's always, every new class, doesn't matter whether it's math, any other class you're taking, you really want to get in the habit of like, what is it that my teacher, uh, wants, wants her, because that's what it's all about. They're giving you the grade, they're the ones, doing all this. So
Got it. And then the next question that I wanted to go over was P7.
sure.
That's the last one.
Sure. All right, here we go. So this one is kind of that standardized test question. They got a lot of word numbers. You got to make sure you get the right one. So six 2-foot tall pine trees were planted during the school's observation of Earth Awareness Week in 1990. The trees have grown at an average rate of 3/4 foot per year. Okay. So um, the thing here is that you have to decide how tall were the trees when they started. Like it's normally X, Y, and that's what I would normally write. But then you got to read this. Okay. Um, height of the tree as a function. So whenever it's the function of, that's your X. And the other one is your Y. So it's again, it's T comma H. Now it's not always T, but it often is. It often is TH. So what is the initial height of the pine tree?
The initial height of the pine tree. um,
It's right here in the beginning.
Up, 2 feet.
Yes. So 0, 2. And then this time they're actually just giving you the slope. When they give you the average rate of change, that is the slope.
Got
Okay.
it.
Okay, so that's nice.
So they
Again,
give
I
you
would just go back to your y equals mx plus b, and then say, okay, well, what is m? M is 3/4. What is b? Well, again, it's 2 because they're giving the ordered pair 0, 2. So y equals 3/4 x plus 2. Is that okay?
Yeah.
And then you switch the variables. You say, okay, it's h instead of y, and it's t instead of x, like that.
Got it. Then, um,
So now that's everything for part A. For part B, it's the graph. This is where, I mean, I don't know if you're using graph paper or not, but you just gotta be, you gotta kind of say, okay, that's 2, that's where it's starting. And then it's going up by 3/4. So 3/4 is hard to go up by. So you might think of it as like, if you go up two years, it's 3/4 doubled. 3/4 times 2 is well, maybe it's easier to look at it as a decimal. It's 1.5. Or 4 years, you go up 4 years, 0.75 times 4 is 3. So like 4 years, it goes from 2 to 5, 3, 4, 5, like that.
got it.
So you probably need to use a ruler. You probably need to make this a little nicer than I did. Are you allowed to use like Desmos to graph these things, or did that all be done by hand?
It's by hand.
Okay. Well, yeah, then you gotta be super neat. So,
And then, so the y-axis would be uh the height
the height, but you gotta give units of measure, so
to
that's in, feet,
the feet. Yeah.
yeah. And then the time is in years.
Mm. And then there would so it'd still be no for C. Should the line have two arrows on both, or two arrows, one or
Yeah,
arrow on both
it,
ends because it's
yeah,
only in one end.
it's at one end, and then it does go on forever, but that's not really true. I mean, trees don't grow forever, but that's the assumption, is they grow for a while. No tree grows forever. I mean, eventually they crash. So
Um, all right. Uh, Now, so that I just put no because the tree cannot go down. So I put the explanation because for the previous one, our teacher said that it would be no, it cannot have negative time
right.
and the ice will melt, so it's not infinite. So
Right.
for
And same
this
thing
one,
here. There's no negative time, but there is yeah, it can grow for a while.
yeah. So now I'd like to go over the homework.
Okay.
Let me All right. Let me put the homework in the chat. I'll tell you the question. So here's the homework. And I wanted to go over 4, 5, 6. Um
Just one at a time. Let's, yeah.
yeah,
Just,
so just a couple in the front and then like the main ones like the word problem. It's on the second page of it. But we'll start off with number 4.
all right, so let me kind of put this back on you a little bit. Well, actually, I take that back. Okay, so 4, 5, and 6, you can see that actually the way that they're trying to get you to do this is they're using what's called the intercept approach. Okay, so the intercept approach is finding the x-intercept is when y equals 0, and then the x-intercept, the y-intercept is when x equals 0. Okay, so y equals 0 means that you're literally putting 0 in for y. So when you put 0 in for y, that part of it goes away. So you're now solving this equation 2x equals 2. Does that
So
look familiar to you?
oh, so yeah, we're using that to find like oh yeah, that makes sense. You plug in the 0 for y and the 0 for x, depending on which intercept we're finding, and then you find the x-intercept. Yeah, that makes sense. 2x. Wait, then wouldn't x be 1?
Yes, you have to actually solve for x. So what that means is when x is 1, y is 0, or vice versa. But we normally do it x comma y. So you get an ordered pair out of this, which is 1 comma 0. Is that okay?
Yeah.
All right. Now for the y-intercept, you put 0 in for x. So it's 2 times 0 plus y divided by 3 equals 2. 0 plus y divided by 3 equals 2. So it's just this y divided by 3 equals 2. And so multiply both sides by 3, and you end up
It's
getting y equals 6. So 0 comma 6. So the idea is, and I mean, you'll do it much faster than this, but this is kind of the worked out. You always need 2 points when you graph. Okay, you always need 2 points. So the x-intercept and the y-intercept are good options because you they're 2 distinct points, 1, 0, and then 0, 6 like that, which is something like that there.
done.
Use a ruler, put arrows on the end. You might even have to put in like X and Y. It depends on how, like you want to study the graphs from your instructor in their notes. Like the way they do it is the way you want to replicate it. That way you'll get, that way they're looking at something that's familiar to them.
Um, ideally, number 5 should also be the same kind of.
Yeah, so why don't you try, I mean, actually they're both the same, but yeah, why don't you try 5 on your own? We got plenty of time here. I just want your x-intercept and your y-intercept whenever you got them.
I got x-intercept of 10 comma 0 and a y-intercept of 0 comma -2.
Perfect. So you want to plot those 2 points on your graph. And something like that. All right, any questions on that?
No.
So what I tell students, and it's hard to, it's almost impossible to show this on the uh, the digital screen, but imagine if you could cover up, like when you do the y-intercept, you're setting y equal to 0. You're effectively covering that up when y is equal to 0. Like you would just put your, like, imagine putting your finger over that and you're just solving 4/3 x equals -4 like that. Is that okay?
Yeah.
Like you don't just put 0 in, you know that when you multiply by 0 or zeros in the numerator, like it goes away. You just ignore it. So then you multiply everything by 3/4. Okay. So x equals -3. All right. So we got, again, get another ordered pair here. -3 comma 0. The y-intercept again is when x equals 0, and I'll re-snip the equation, but it's essentially you're covering up now that variable. So you're covering this up right here. Remember that operator goes with the number to the right. So it's just -2/5 y equals -4 like that. Is that okay so far?
Yeah.
Okay. Now to solve this type of equation, you always multiply by the reciprocal. So 5 over -2, 5 over -2. And so, these cancel, these cancel. If you want the negative to be in the top, that's fine. -20 over -2 is +10. So it's 0 comma +10 like that to get your ordered pairs.
Alright. Okay. So I got that.
Again, you'd graph these and -3, 0, 0, 10, something like that. Did you cover horizontal and vertical lines?
Horizontal and vertical lines, yes. Where, yeah, that was that was part of our lesson 4. This one's mostly just this is just graphing the horizontal lines that you between this one. For example, like the one that says y equals -8, number 7. Um, that would just be it. So it's y equals -8, it'd be a horizontal line at
You
the
just got to know
y
the difference
value
between them.
-a. Yeah.
Let me know when you're ready. We can move on to next question there.
Alright, second page. Alright, so now we're at number 13. So, another question.
Okay, so again, like it's kind of like the ones we were just doing on, not just doing the ones that you first started out with. It's X, Y, but this time, is it WC or CW? And it really comes from those words function of, function of.
So it would be C of W.
The function of, that's the input. W is the input.
Oh, yeah. So it'd be,
And that's really important. If you flip those, you have no chance of getting it right. So from here, could you write the two ordered pairs from this original part?
yeah. So I got 140 comma 1560, or 1560, and then 180 comma 1700 as the coordinates. All right. So,
All right, sorry about that, Karthik. So you should have gotten 140 comma 1560
yeah,
and 180 comma 1700. And then from here, you have to find the slope.
this M. I got 7/2.
Okay. Let's see here, 140 or yeah, 7/2. So maybe 3.5 like that. So this one's a little bit more difficult because when we get the y equals mx plus b, we have the slope. It's 3.5x plus b, but we don't have the b value this time. We have to use one point or the other. And it doesn't matter which one. It's totally up to you which one you use. But like, does one of these equations stand out to you more than the other? Points. Do either of these points stand out to you?
Really?
So you just pick one. You
All
want to pick
right.
the first one or the second one?
We'll just do 140 comma 15
Okay.
60 for the first one.
So 1560 equals 3.5 times 140 plus B. 3.5 times 140. 1560. So 1070 equals B. Sorry, that's not that B. B. So it's Y equals 3.5x plus 1070. So you get that number, you subtract it, you get 1070 equals B. And then from here, again, you got to make sure you have to make sure that you're using the right variables. So it's always good to go back to this mapping of variables, X, W is really X and C is really Y. So we got C equals 3.5 W plus 1070 like that. That's part A.
Alright. And then part B, sketch a function and label the axes.
Yeah, so kind of, you can see the pattern here. Like if you're wondering what a test question is like, it's that you're going to write the equation, then you're going to graph it. So I don't know if you have to be really like if this is really all you're given, you could do this a lot of ways. I would probably go up here like 1070 and then draw a line kind of flat because that's what's happening. W is the weight in pounds. And C is the calories. Like that.
Alright. Maybe no.
We've kind of already answered part C, which is, should there be arrows on both ends? And most of the time it's no in these real life examples. And it's it's you might even pose the comment to your your teacher and say, well, I know we go to the right forever means someone could be like 5,000 pounds, which is ridiculous. Like there is an upper limit to like what the human body can stand. Skeletal structure, right? Like I don't know how much of a kind of student you want if you're that kind of student, but I mean, even someone that's like 600 pounds that's pretty big. I mean, like this actually does not go on. But maybe you point that out to them. I don't know. That's if you're want to kind of engage in the realistic expectations of the class. So I don't know. You can decide that later on if you want.
Alright.
But it could go to the right for a while because people could you can be anywhere from I mean even over here on the left it's not zero, it's I mean nobody's 0 pounds like but that's the idea. So just something to think about. Yeah.
And then going back to up to the notes that we did first. So I think the most key thing for example 6 all the way up there would be the what do you think is something we should probably remember for like the task? Like, we are gonna have a we aren't gonna have a quiz on the last 2 lessons alone, but we are gonna have like it's gonna be cumulative of all the lessons. So And she did say that the example 6 has a higher chance of being on the test. I did note that down.
That's
Uh,
good. I mean, that's kind of stuff you got to pay attention. You got to say like, what's going to be on the test. So example 6 is just this word problem. Like we've done now 3 of them where you get,
so all of them pretty much have the same structure, like
yep,
asking you to write
exactly.
the linear equation,
Yep.
asking you to graph it, and then or sketch it, and then like just explaining if it should have 2 arrows like on the
Yep.
ends, pretty much. That's all we've pretty much done today, except like for the exception of 4, 5, and 6 on the homework. Uh, and then for 4, 5, and 6, you just replace the x and the 0 with a 0 or the y with the 0, depending on like which intercept you're
Yep.
trying to find. Got it. Um, and then on the notes PDF that I sent in the chat, um, at the very top of the notes, I don't think we went over it quite, but the part where it says standard form, that would just be you converting it to y equals mx, or that would you just replace it with 0, again, depending on which one you would probably be
Well,
interested
so
in.
like sometimes they have you do, let me find one from your, so sometimes they ask you to put something in standard form. And let's go back to 4. Because that's what I was originally gonna have you do, is put like 4 in standard form. So standard form is ax plus by equals c, and there's like constraints. So the first constraint is that x and y are on the left. Okay, see how they're on the left?
Mhm.
And then the second thing here is that a, b, and c are integers. Like no fractions, no decimals. So see how there's a fraction here? That's bad. Okay. Third thing is that a has to be greater than 0. So a has to be positive, basically.
Got it.
All right, so we're going to multiply everything by 3. Okay, to get rid of that. So we're gonna multiply everything by 3. 6x plus 3y over 3 equals 6. The 3's cancel. 6x plus 1y equals 6. This is in standard form. Does that make sense why it's in standard form?
Yeah.
All right. 5 here. I'd like you to try putting this in standard form, please.
Okay. I guess so. X over 5 minus y. Yeah. I got x minus 5y equals 10
Perfect.
by
Now the other,
multiplying the 5
yeah,
on both sides.
yeah. So the other types of problems you'll see is where, for example, actually there's a bunch of these we can do. But let's just do this one. So something, this is not a great example, but this one would be, it would be the same thing, like put this in standard form. Okay. So generally you move left. So you would subtract 3x from both sides. And you'd write minus 3x plus 1y equals -1. Multiply by -1 now, because that leading term is negative. It can't be negative, so you have to multiply everything by -1. 3x minus 1y equals 1, like that. And there is your final answer. But sometimes you get a problem like, put this other one here, where you move that X term to the other side of the equation. So you have 2/3 X plus 1Y equals 4. And you multiply everything by whatever it takes to get rid of this fraction. So typically it's whatever the denominator is. So in this case, you'd multiply everything by 3. So it'd be 2X plus 3Y equal 12.
Got it.
Okay. If you got that, let's see if there's any. We have you try. Go back to the other one. Just have you try this one here. All right, so why don't you put this in a standard form for me, please?
I got 2x plus 3y equals -9.